Okay, here we go, 12:4, I'm recording, okay? By the way, everyone, just so you know, I looked at the review for the final, and it does have about 3 matrix problems on it. So I do think matrices are going to be on the final, just so you guys know, okay? Okay, so look at this matrix A right here, okay? So you guys, rows go like this. Look, this is a row and this is a row. So this thing has 2 rows. When you give the size, you go like this, you guys. You go rows by columns is how you do this. So matrix A has 2 rows, so it's a 2 by. And then the number of columns, those are the up and down. So we've got 1, 2, 3 columns. So this size of that matrix is a 2 by 3. Okay. And it says that there are 6 elements in there. I don't think that's ever even going to come to play, but elements are just numbers. So if it's a 2 by 3, there are 6 numbers in that. Okay. So example 1 is like crazy easy. They just want to know the size. Okay. So you have 1 number going down, so that's a 1 by. How many numbers going across? 1. So it's a 1 by 1. Okay, nice and easy. Question B, 3 down, 1 across, 3 by 1. Question C, 2 down, 4 across, 2 by 4. Make sure you don't write 4 by 2. It's down and then across. Okay. All right, question 2. Lots of this whole first half of this lesson is easy, pretty easy. Okay, you guys look, we have one matrix equal to another matrix. So what you're going to do is this. You're going to write the top left thing, then you're going to write the equal sign, then you're going to write the top left thing. Those things must be equal. So that would mean 3 equals 3. Okay, then you're going to do the top right. That would give you x equals 5. Then you're going to do the bottom left. That would be y minus 1 equals 6. Then the bottom right, 4 equals 4. So the directions ask you to find x and y. Great that 3 equals 3 and 4 equals 4, but that doesn't help me to find x and y. I do know that x is 5. I got that already. And y minus 1 equals 6. Bring your 1 over. That gives you y equals 7. Okay, those are your answers. Now, listen to this. You do not have to write this as 5, 7. The reason you don't have to write it as 5, 7 is because it wasn't given to you as equations. So if you start as equations, write it as an ordered pair or an ordered triple. This one wasn't like that, so you don't need to. Okay? All right, example 3, A and B is super easy. So this right here just means take 5 and multiply it by matrix A. So here's 5, and then you write down matrix A. All you do is just multiply all those numbers by 5. So you just go 1 times 5 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20. Very simple. It's called scalar multiplication. Question B is the same thing. Keep in mind, you guys, that all those signs are going to change. So 4 times negative 3 is negative 12. Negative 1 times a negative 3 is a positive 3. 0 times negative 3 is a 0. 4 times negative 3 is a negative 12. Negative 3 times negative 3 is a positive 9. 8 times negative 3 is a negative 24. Done. Okay? Very simple. All right. Now we're going to add some matrices. Okay? So this is example 4. So in order to add or subtract, okay, so it says it right here. To add or subtract 2 matrices, they must have the exact same order. They must be the exact same size, or you can't add those together. So whenever I do a problem like this, you guys, where they give me like lots of different matrices, the first thing I do is I write down the size of all of them. So matrix A is 2 down and 3 across, so it's a 2 by 3. Matrix B is also a 2 by 3, and matrix C is a 2 by 2. Okay, so they want me to take matrix A and add it to matrix B. Well, A is a 2 by 3 and B is a 2 by 3, so we're good to go. Okay, on these notes, If you're just adding one matrix to another matrix, you don't have to write this down, but on the notes, let's do it. Okay, so on your homework, you could just go right to the answer. So put matrix A and add it to matrix B. And this is so easy, just like what we've done so far. You just add the numbers in each location. You don't change the signs, you just combine those. So a -2 and a +4 is a +2. A +1 and a -2 is a -1. 3 and 0 is a 3. On the bottom, 3 and 0 combined gives me a 3. A -1 and a +1 is a 0. 5 plus 2 is a 7, and I'm done. Okay. Question B, add C to A. Somebody talk to me about that. Why can't you do that? They're not the same size, okay? So we're just going to write down not possible, and we're done. That's all you do, okay? Question C, A minus B. You can do it, okay? So let's write down matrix A exactly the way you see it. And then let's write down a minus, and then I want you to write down matrix B. This is important because this messes people up, so I want you to listen closely, okay? And we would only be so lucky that a problem this easy would be on the final. That would be awesome. So see this negative? I don't want it there. The only thing that I ever want you to have in the center is a positive, okay? So the first matrix is not going to change. Let's write that one down. And then as far as that negative goes, what you're going to do is you're going to take it in and you're going to multiply all those things. You're just distributing it in. So you're going to have a -4, a +2, a -3, a 0, a -1, and a -2. Okay? Then you add those numbers together. So a -2 and a -4 is a -6. 2 plus 1 is 3. -3 and 0 is a -3. 3 and 0 is a 3. A -1 and a -1 is a -2. 5 minus 2 is a 3. And I'm done. Nice and easy, right? Nice and easy. Okay, question 5. Okay, tell me what page we're on, would you please?
93.
Thank you. Okay, question B. So this one is more complicated, okay? So this is what I want you to do. I want you to write down matrix B, okay, which is 4, -2, 3, underneath 0, 1, 2. Then I want you to go -2, and then put down matrix A. So I literally want you to set it up just the way it's read, okay? -2, 1, 0, 3, -1, +5, okay? The first matrix has no change. You just write it down. Remember that the only thing I want you to ever have in the center is a plus. So if there's ever anything in front, I want you to distribute it through and get rid of it. So a -2 times a -2 is a +4. -2 times 1 is a -2. 0 times -2 is a 0. 3 times -2 is a -6. A -2 times a -1 is a +2. 5 times a -2 is a -10. Do you see how clear and clean and organized it is, so I'm not going to mess up? So now I add it, and I get 8, -4, 3, underneath -6, 3, -8, and we're done. That's it. Okay? Easy, easy, right? Okay, now we're going to multiply, and multiplying might stress you out, okay? So I just want you to stay super calm when you multiply, okay? Here's what you need to remember about multiplication, okay? I'm just going to say, we're going to just write it, okay? So everybody write this down. Put middle numbers must match. Okay, let me give you an example. Let's put EX for example. This is when you're multiplying. If you have a 2 by 2 and you're trying to multiply it by a 3 by 2, you look at those middle numbers right there, and do you see how they are not the same? Then you can't do it. So this one right here is not possible. Okay, let me give you another example. This is important. You're going to want to write this down. If you have, bless you, a 2 by 2, and you're trying to multiply it by a 2 by 3, look at the middle numbers, they match. So it's possible, okay? Here's something that's important. Write down that the answer will be, if you get rid of the things that match, the 2 and the 2, what do you have left? A 2 by 3. So the answer would be a 2 by 3, okay? That's important that you understand that. Okay, so here are these 4 matrices. Let's start by writing the order of all of them, okay? So A is a 2 by 3, B is a 2 by 3, C is a 2 by 2, and D is a 3 by 2. You guys, listen right here. This is important as well. Question A and question B. C times A and then A times C, they are not the same. So in regular math, if you have 2 times 3, is that the same as 3 times 2? Yeah, they're both 6, right? In matrices, that is not the case, okay? So let's write down the order of C. C is a 2 by 2. I'm trying to multiply it by matrix A, which is a 2 by 3, and I can do it. I know my answer is going to be a 2 by 3, okay? All right, let's write it down. So you have to write C first. So go 2, -2, -3, 3. And then right next to it, write down matrix A. Okay, now here's where the confusion starts, okay? I know you've done this before, but for so long you've been able to do matrices on your calculator, so now you've forgotten how to multiply them. So now I have to remind you, and it's a little complicated. First of all, I know the answer is going to be a 2 by 3. So literally, I'm not exaggerating or lying. Every time I do this, I set my answer up, what my answer will look like. So I know I'm going to have 2 numbers going down, 2 rows going down, right? And then I'm going to have 3 columns going across. Some people ask me, what are those little notches? It's for row, row, column, column, column. Do you have to do that? No, I always do, okay? All right, now listen closely, okay? I'm going to go slowly. From this number, you only use rows. That's all you're going to use. From this matrix, you're only going to use columns. Okay? So here's what you do. Nice and slowly. Bless you. You take this row, the first row, and you take this column, the first column. Okay? And you have to pair those things up. Okay? Now what I want you to do is I want you to just look forward for a second, because you have to understand how this thing rotates, okay? So this is the first number, and this is the second number. So first number, second number. What happens is they turn like this. So first number, second number. Over here, first number, second number. So the 2 goes to the -2, and the -2 goes to the +3, and you multiply it. So when you flip it, you go 2 times -2 is a -4, and -2 times a +3 is a -6, and -4 and a -6 gives me a -10, and that's that number that goes right there. Okay? Now, once I do that, I change columns. So now I'm over here, and I'm going to use this column right here. Once again, it goes like this. Okay, watch the rotation. First number, second number, first number, second number. So it goes like this. Boom. So the 2 goes to the 1, the -2 goes to the -1. Okay, so you go 2 times 1 is 2. -2 times -1 is a +2, and 2 plus 2 is 4. Okay, yes, honey? You just combine them. So you never change signs, but it's not always technically addition, because if you have a -10 and a +6, you're really subtracting those. You know what I mean? But don't change any signs, is what you're saying. Yes, you are correct. Do not do that, okay? Okay, here's the next one. Now I'm going to go 0, 5. So the 2 goes to the 0, the -2 goes to the 5. So 2 times 0 is a 0, -2 times 5 is a -10, that just gives me a -10. Okay, who says, I'm with you, I'm good. Okay, great. Well, now what do I do? Because I'm out of columns, right? So now you change rows. Good. So this row is gone, and now I'm using this row right here. Okay, so watch the rotation, okay, so that you understand. Look right here. First number, second number, first number, second number. So the -3 goes to the -2, the 3 goes to the 3. That's the rotation. Okay, so a -3 times a -2 is a +6. 3 times 3 is 9, and 9 plus 6 is 15. Now I'm going purple to blue. A -3 times 1 is -3. Sometimes I even do this. I'll just write it down so I don't have to remember. 3 times -1 is a -3. A -3 and a -3 is a -6. You don't have to do that. -3 times 0 is 0. 5 times 3 is 15. That gives me a 15, and I'm done. That's my answer. Okay? Who says I got it? Let me see. Okay. I will tell you, there is a matrix multiplication on the final exam review. So I'm thinking it's going to be on the final, which would be good news, because I think that this is manageable. Okay? Okay, let's do A times C. So A is a 2 by 3, and C is a 2 by 2. Somebody talk to me. Can't do it, right? So we're going to write the words not possible, and we're done. I always check if I can do it at the beginning, otherwise I'm going to get confused. Okay? Okay, question C. D is a 3 by 2, and C is a 2 by 2. Can I do it? Yes, I can. When I do it, the order of the solution is a 3 by 2. There used to be a question on the final that says, if you multiply a 3 by 2 by a 2 by 3, what's the order of the solution? 3 by 2. That's all you have to do. Okay? I would love it if we had that. Okay, here's question D. Or question C. Write down matrix D. Right next to it, put C. You cannot do C and then D. You have to do it in the order they give you. Okay? Okay, now I like to get my answer set up. Okay, so I know my answer is going to look like this. 3 numbers down, 2 numbers across. It just helps me get organized. Okay? Okay, here we go. This row, and then this column right here. Okay? So the 2, the 1 goes to the 2, the 3 goes to the -3. So 1 times 2 is 2, 3 times -3 is a -9, 2 minus 9 is a -7. Okay? Change columns. So now I'm doing this guy right here. The 1 goes to the -2, the 3 goes to the 3. 1 times -2 is a -2, 3 times 3 is a +9, a -2 and a +9 is a +7. Okay, and now I'm out. So this is gone, and now I'm going to change rows. So I'm changing this. So -1 times 2 is a -2, 0 times -3 is a 0, a -2 and a 0 gives me a -2. Now I'm going purple to green. -1 times -2 is a +2, 0 times 3 is a 0, 2 plus 0 is a 2. Now I'm done with that row, so now I change rows here. 2 times 2 is 4, 4 times 3 is a -4 times a -3 is a +12, 12 plus 4 is 16. 2 times -2 is -4, a -4 times 3 is a -12, combined I get a -16. There's my answer. Okay? Who says I'm good? I'm great. Let me see. Okay, good. I really think it's been okay so far, personally. Okay, here's some true-false questions that I've seen before. Is it true that A times B is always going to be the same as B times A? Yes or no?
No.
That is false. Okay. I'm just going to put false. Okay. If A and B are square matrices, then A minus B squared is A to the second minus 2AB plus B squared. Okay. So look right here. This is going to just blow your mind. Look right here. A minus B squared. You can just watch. It's A minus B times A minus B. That's A to the second minus 2AB plus B squared. So in real math, this is equal to this. Well, what about when we're talking about matrices? So this came up. I've seen one or both of these on finals. So literally, I think we hadn't even talked about it, and my students had to figure it out, and I think most of them just guessed, to be honest with you. So you know what I did? I made up two matrices. They have to be square matrices. We have not talked about that. If it's a square matrix, then the rows and the columns are the same, like 2 by 2, 3 by 3, whatever. So what I did is I made up a matrix A. That was easy. I made up a matrix B, which was also easy. Something like that. I figured out what this is, figured out this, added those together, saw if they matched. Took me a long time. Took me probably 5 minutes, 4 minutes, something like that to do it. So I'm just going to tell you that the answer is false. It does not work out. So you're just going to have to remember, if you have something like that on a final, either one of these, the answer is false. If you are asked to support your answer, justify your answer, then you're literally going to have to do this. You're going to have to make up an A, make up a B, subtract them, get a new matrix, square it. By the way, when you're squaring a matrix, let's say you have 2, -1, 4, -3, and that thing's supposed to be squared. You would have to write it twice, like this, right next to each other. And then you'd have to multiply that together to get your answer. Who says, I understand what you're saying? Raise your hand. Okay, great. Then here you would have to write A by itself, multiply, A times B, distribute in a negative, B times B, then add those three matrices together and see if it equals the left-hand side. Lots of work, okay? The answer is false, okay? I think that's sufficient explanation for those two. Who says, I agree? That's sufficient. I understand what you're saying. Okay, great. Okay. Identity matrix, we've already talked about this, okay? If it's a 2 by 2 and a 3 or a 3 by 3, that's the identity matrix. Some people, I've seen a student or two do like this crazy matrix problem, and they did the whole thing right, only they wrote that as the identity. Your whole problem's gonna be wrong. So just be careful that the diagonals go across the correct diagonal. Okay, question 7. Show that these are inverses, okay? If it says show, then they must be inverses. So here's what you do. You take matrix A, you multiply it by matrix B, and you're supposed to get the identity, if they really are inverses. Then the reverse is true. B times A is also the identity, okay? Now you can't just do that. You have to write A and B down, okay? So let's write A down. Right next to it, write B. And when you multiply those, you're supposed to get the identity. Now, I'm not asking you to be a liar, okay? But if it said show, and you know it's true, and you know that when you multiply them, you're supposed to get the identity, if you write that down, and you really don't multiply those, because you know it's supposed to be the identity, would I ever know? Would I ever know that you truly did not multiply those together, yes or no? I would never know. Do you understand what I'm saying? It's supposed to be the identity. It says show. It must be true. Literally, you could just write that down. Okay, let's do the other way. So B would be -3, 1, 0, 4, -1, 0, -2, 1, -1. Right up against it would be matrix A, which is right here. And I know when I multiply those, I'm supposed to get the identity, which looks like that. Okay? Literally, you would get full credit for writing that, because when you multiply matrices, there's no work to show. Okay? Now, just look right here for 2 seconds. Let me do a couple of things. Okay? Look right here. This row times this column. Okay? 1 times -3 is a -3. 1 times 4 is a 4. 0 times -2 is a 0. Add those together, I get a 1. Change columns. This is the column I'm doing now. So I would go 1 times 1 is 1. 1 times -1 is -1. 0 times 1 is 0. Combine, I get a 0. Change columns. Okay, so now I'm looking here. So I would go 1 times 0 is a 0. 1 times 0 is a 0. 0 times -1 is a 0. I get a 0 there. Do you see what I'm saying? You could fake it and nobody would ever know, because I didn't show any work and I just multiplied those three things together. So the point is that if things are inverses, you multiply them one way and you must get the inverse. You multiply them the other way, you must get the inverse. If it says show, then I know it's going to work, and I could just literally write it down like that. Okay? Who says I understand? Raise your hand. I gotta see how we're doing. Okay, great. Okay. Not every matrix has an inverse. Okay. If it doesn't have an inverse, it's called singular. And we can actually find a matrix. Okay. So this is leading us up to another method of solving matrices. It's called matrix algebra. Okay. To find an inverse, here's your formula, okay? You put A on the left, you put the identity on the right. Then you manipulate the matrix so you have the identity on the left, and what you have on the right is the inverse, okay? So this is a very simple matrix. It's very small. We're going to find the inverse, okay? So let's set it up. Put matrix A on the left, put the identity on the right. Now I have to turn this into the identity, okay? So someone over here asked me, what's the order that you switch a 2 by 2 into the identity, right? That was at the beginning. It's this, 1, 2, 3, 4, okay? Now, I do want to say this to you. I'm glad this is happening, so everybody look right here. So this is supposed to be a 1. I could turn it into a 1 easily by dividing by 2. But if I divide by 2 right now, it's going to make this guy right here a fraction. I don't want to deal with fractions. So I'm going to blow that off. I'm going to do it later. I'm going to move to step number 2, which is making that 4 a 0, which is going to be easy. So I'm going to go a -2 times row 1 added to row 2 becomes my new row 2. So do you see how sometimes I really don't follow the correct order, because I do not want to deal with fractions, okay? So let's multiply the top by -2, and you get -4, 8, -2, and 0. Write row 2 underneath it, 4, -7, 0, 1. Add those together and you get 0, 1, -2, +1. The next thing I need is a 1 right there, and it was a total bonus because when I switched the 4 to a 0, I also switched the -7 to a 1. So I got 2 for 1. Okay, so now I'm moving to the -4. I need that -4 to be a 0. So I'm going to multiply the 1 by a 4 and add them together. So I'm going to go 4 times row 2 plus row 1 becomes my new row 1. So row 2 doesn't change. Multiply row 2 by 4 and you get 0, 4, negative 8, 4. Put row 1 underneath it. Add those together and you get 2, 0, negative 7, and 4. Well, now I'm forced to turn that into a 1, and I'm still going to get fractions, but who cares because my problem's done. You know what I mean? Doesn't matter to me. So I'm going to go row 1 divided by 2 becomes my new row 1. So row 2 doesn't change. Divide by 2 and I get 1, 0, negative 7 halves, and 2. So the question is, what's the inverse? You guys, this is your answer, but you have to write it correctly. So everybody write a to the negative first power. That's the symbolism for the inverse, is negative 7 halves, 2, negative 2, comma 1, and that is how you write your answer. Okay? All right. Let's find this inverse, okay? This is going to be a big old pain. It's going to be as ugly as Gauss-Jordan. Only worse, because this is 9 numbers, plus the 3 on the right last time made it 12. I have to manipulate 18 numbers, because I have a 3 by 3 and a 3 by 3. So it's just the same thing, just more numbers, okay? Okay, here we go. Let's write matrix A on the left. If you know how to do Gauss-Jordan, you're going to be fine with this, okay? On the right goes the identity. Okay, I have to turn the left-hand side into the identity. The first thing I need is a 1 right there. Done. The second thing I need is a 0 right there. You could do row 1 minus row 2 or row 2 minus row 1. It doesn't matter. I'm going to go row 1 minus row 2 becomes my new row 2. Okay, so row 1 doesn't change. Row 3 doesn't change. Row 1 minus row 2. 1 minus 1, 0. 1 minus 2, negative 1. Everybody stop right there. That negative 1 is almost what I need in that center position. What do I need in the center position? A 1, right? So how could I make that end up being a 1 and not a negative 1? What could I do? Flip them, yeah. So let's just stop and reevaluate. I'm going to go row 2 minus row 1. If I do row 2 minus row 1, I'm going to get a 2 for 1, okay? And that's a good thing. So row 2 minus row 1. 1 minus 1, 0. 2 minus 1, 1. 1 minus 0, 1. 0 minus 1, negative 1. 1 minus 0, 0. 0 minus 0, 0. Okay? The next thing I need is a 0 here. Use the 1. So go negative 2 times row 1, added to row 3 becomes my new row 3. Okay, so row 1 doesn't change. Row 2 doesn't change. Multiply row 1 by negative 2. And you have negative 2, 0, negative 2, 0, 0. Put row 3 underneath it. Add those together and I get 0, 1, 2, negative 2, 0, 1. Yes?
So in column 2, like on the inverse side, not
Okay.
on the other side, shouldn't you have a 1 in the center still? Because you were subtracting it by 0.
Yes? Is he right? Did I mess up? Okay, row 2, yes. Row 2 minus row 1, thank you. So 1 minus 0 is 1. So this guy right here should be a 1, okay? Now, that does not affect the next matrix that I just found because this formula does not involve row 2. So let's just come over here and change that to a 1. Thank you. Thank you. Okay, the next step is getting this guy to be a 1. It's done. The next step is getting that guy to be a 0. Okay, now I could do row 2 minus row 3 becomes my new row 3, or I could do row 3 minus row 2 becomes my new row 3. They both work. You can't use row 1. Remember, we learned that last time. If you choose wisely, you'll get a 2 for 1. So do I want to go 2 minus 3, or do I want to go 3 minus 2? Tell me. 3 minus 2. Because if I do 3 minus 2, then my 2 here in this corner will also become what it needs to be. Okay? If you have a hard time figuring that out, just go for it and then fix it. It's not that big of a deal. Okay? So row 1 stays the same. Row 2 does not change. Go row 3 minus row 2. 0 minus 0, 0. 1 minus 1, 0. 2 minus 1, 1. Negative 2 minus a negative 1. That's a negative 2 plus 1, which is a negative 1. 0 minus 1, negative 1. 1 minus 0, 1. The next thing I'm supposed to get is a 1 in the corner, and I did. So the next one after that is a 0 here. You tell me, should I do row 2 minus row 3 or row 3 minus row 2? Talk to me. I'm going to write them down because nobody's answering me. Okay, so everybody go row 2 minus row 3 becomes my new row 2. Row 3 minus row 2 becomes my new row 2. It matters. It is 2 minus 3. Because if I do 3 minus 2, you get a negative. Can I recover from a negative? Yeah. Yes, I can. But why do more work? So if you just think a little bit, you can get the right sign. You can sometimes get a 2 for 1. Okay, so row 1 doesn't change. Row 3 doesn't change. Row 2 minus row 3. 0 minus 0, 0. 1 minus 0, 1. 1 minus 1, 0. Negative 1 minus a negative 1. That's a negative 1 plus 1, which is a 0. 1 minus a negative 1. That's 1 plus 1, which is a 2. 0 minus 1, negative 1. Okay, the next thing I need is a 0 here, and it's done. So I only have one more step, and that's getting a 0 in that top center. Should I do row 1 minus row 2, or should I do row 2 minus row 1? Talk to me. 1 minus 2, right? So row 1 minus row 2 becomes my new row 1. Okay, so row 2 doesn't change. Row 3 doesn't change. Row 1 minus row 2. 1 minus 0, 1. 1 minus 1, 0. 0 minus 0, 0. 1 minus 0, 1. 0 minus 2, negative 2. 0 minus a negative 1, that's 0 plus 1, which is a 1. What if you did that whole thing and then you didn't write your answer the way that they wanted you to? My guess is, I'm not exaggerating, I bet they'd take off half of it. That's just how it's going with this new midterm and final, the way they're doing it. So your final answer is my inverse is 1, negative 2, 1, 0, 2, negative 1, negative 1, negative 1, 1, and now I'm done. Okay, who says, I understand? Let me see, give me a big raise. Okay. Now, we haven't even used the method that we're supposed to be learning for this lesson. We haven't even learned the method yet. We've learned how to find an inverse, but we haven't learned the method. Okay, everybody listen. you're smart. Last year in secondary 3, or in secondary 3 honors, I want you to try to remember, when you solved a matrix in your calculator, you put in matrix A, which is here. Then you put in matrix B, which is here. You just clicked them in your calculator. Does anybody remember the buttons that you hit to solve it, to actually come up with the x, comma, y, comma, z? What do?
You have to do it to the number.
You have something about negative first. Yeah, do you remember?
Like you times it. You did a matrix.
You take what matrix? You take A
Negative A.
to the negative first. Keep talking. Everybody help her. Come on. You times it by B, and that gives you your answer. Okay? So listen what we're going to do. We're going to find the inverse. Then once we find the inverse, we're going to multiply it by B, and we're going to get our answer. Okay? So we're going to do it just like we did on the calculator. Okay, here we go. Almost done. The next one is a breeze. Okay? The next one takes not long at all. Okay? Okay, so 1, 1, 0, underneath 1, 2, 1, underneath 2, 3, 2. The right-hand side is the identity. This is called matrix algebra. I think there will be at least 3 matrix questions on your final. That's my guess, okay? Okay, here we go. Turn it into the identity. The first thing I need is a 1 right there. Done. The second thing I need is a 1 right there. Now let's see if you can answer this question. I could do row 1 minus row 2, or I could do row 2 minus row 1. They both work. One's better. Which one's better? 2 minus 1. It's a 2 for 1. Okay? So row 2 minus row 1 becomes my new row 2. Okay? Row 1 doesn't change. Row 3 doesn't change. Row 2 minus row 1. 1 minus 1, 0. 2 minus 1, 1. That's why I did row 2 minus row 1, so I could get that 1 right there. 1 minus 0, 1. 0 minus 1, negative 1. 1 minus 0, 1. 0 minus 0, 0. Now I need to get a 0 here. Use the 1. So go negative 2 times row 1, added to row 3 becomes my new row 3. Row 1 doesn't change. Row 2 doesn't change. Take a negative 2 across row 1 and you have negative 2, 0, negative 2, 0, 0. Write row 3 underneath it. Add those together. Always add, never subtract. Just change the signs and then add. It's so much easier. So this is 0, 1, 2, negative 2, 0, 1. The next thing I need is a 1 here. Done. So now I need a 1 here. I could do row 2 minus row 3, or I could do row 3 minus row 2. Which one's better? 3 minus 2. Yep. Row 3 minus row 2 becomes my new row 2. My new row 3. Okay? So row 1 doesn't change. Oh, by the way, I'm sorry I didn't say this before. When you're doing matrice homework, you don't have to fold your paper in half. I know now that's a big, you know, 2/3 of the matrice assignments are done, or 3/4. Anyway, you don't have to fold your paper tonight, okay? I'm very sorry about not announcing that earlier. Okay, row 2 doesn't change. Row 3 minus row 2. 0 minus 0, 0. 1 minus 1, 0. 2 minus 1, 1. Negative 2 minus a negative 1. That's a negative 2 plus 1, which is a negative 1. 0 minus 1, negative 1. 1 minus 0, 1. The next thing I need is a 1 right there, and I've got it. So after that, it's that one right there, okay? I could do row 2 minus row 3, or row 3 minus row 2, and the best option is row 2 minus row 3. Becomes my new row 2. Otherwise, your signs get messed up. Row 1 does not change. Row 3 does not change. Row 2 minus row 3. 0 minus 0, 0. 1 minus 0, 1. 1 minus 1, 0. Negative 1 minus a negative 1. That's a negative 1 plus 1, which is a 0. 1 minus a negative 1. That's 1 plus 1, which is a 2. 0 minus 1, negative 1. The next thing I need is a 0 here. Done. So I only have one more thing to change, and that's that 1. I could go row 1 minus row 2, or row 2 minus row 1. I'm going to go row 1 minus row 2. Otherwise, I'm going to make that 1 in the corner a negative 1. Okay? So row 2 doesn't change. Row 3 doesn't change. Row 1 minus row 2. 1 minus 0, 1. 1 minus 1, 0. 0 minus 0, 0.
Excuse me, I'm gonna need the key to open that box.
Sure, no problem. No problem.
She's asking me, I can flip myself on when I get back to the key.
That's okay. That's all right. Do you mind having a student pen like that?
Yeah.
Thank you. Okay, sorry about that. So 1 minus 2. So 1 minus 0 is a 1. 0 minus 2 is a negative 2. 0 minus a negative 1, that's 0 plus 1. Okay, now here's how you're going to write this up. Okay, everybody go. A to the negative first equals 1, negative 2, 1. 0, 2, negative 1. Negative 1, negative 1, 1. Okay. Then I want you to write down A inverse times B equals. Okay, so you write your inverse. Right next to it, you put B. What is B? The right-hand side of the original, which is, what is it, honey? 20, 30, great. 20, 30, 55. Right? Now, the inverse is a 3 by 3. B is a 3 by 1. Can I multiply those? Yes, I can. The answer is going to be 3 numbers down, 1 number across. Okay, so now I go this row times this column. So I go 1 times 20 is 20. You can just put them on my desk, honey. Thank you. Negative 2 times 30 is a negative 60. 1 times 55 is 55. Combine, and I get 15. Change rows. So I'm going to go this row times the yellow. 0 times 20 is a 0. 2 times 30 is a 60. Negative 1 times 55 is a negative 55. Combine, and I get a 5. Okay. Last one, right here. Negative 1 times 20 is a negative 20. A negative 1 times 30 is a negative 30. 1 times 55 is 55. Combine those, and I get a positive 5. Right? So my solution is 15, comma 5, comma 5, and I'm done. It's called matrix algebra. Is this problem checkable? Answer that.
Yes.
How fast can I check it?
So easy to swim.
A minute. This problem took us probably 7 minutes. Is it worth taking a minute to check it? If it's a quiz or a test, you bet. Of course I would. Okay? Question. Go ahead, sweetheart. Yes. Did you have a question? You're good now? Okay. Okay, here's question 11. Here's your A. Here's your inverse. Use your inverse to solve. Okay? Everybody just freeze right there. This showed up maybe 3 years ago. and many cents. Okay, look what my students did. Blah, 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 blah. 8 minutes later. Do you need to do that? Why not? They give it to you. So if you do that, you're just going to end up with what they gave you. So they're helping you. Okay? Okay, so let's do it. Write down the inverse. Right next to it, write matrix B, which is the right-hand side. 4, negative 5, 2. And multiply. Your answer is going to be a 3 by 1. Okay? So this row
Teachers, please pardon this interruption.
times this
If
column.
we could have everybody involved with Save It or Shave It, please come down to room 1801. Thank you. And
What is that? Tell us, tell
During
us.
lunch for Save It or Shave It.
You
Thank you.
donate to one person and then the person they're against, so like. you're
It's a
against
competition.
Ivy, so if Ivy gets more money, Cameron has to cut his hair. If Cameron gets
Cut
more
your
money,
hair?
Ivy has to cut his hair.
No. All the way off, bald?
Yeah, but...
Oh my gosh. When? And you're nice to do it. When's that?
Wednesday.
If you're the one that gets shaved, can we like rub it? For good luck? It's good luck. Okay, go for it. You have nice hair. You have like long boy hair. I know. Well, that's nice. It's for a good cause. Okay, let's do this. A negative 2 times 4 is negative 8. A negative 1 times a negative 5 is a positive 5. 1 times 2 is a 2. Combine those, you get a negative 1. Okay? Change rows. So 5 times 4 is 20. 5 times negative 3 is negative 15. 2 times negative 1 is a negative 2. Combine, and I get a 3. Change rows. Right here. Negative 1 times 4 is negative 4. Negative 1 times negative 5 is a positive 5. 0 times 2 is a 0. It's right there. Negative 1, comma 3, comma 1 is your solution. Can you check it?
Yes.
Yeah. Plug it in, get a 4, plug it in, get a negative 5, plug it in, get a 2, done. Okay?